Hey everyone, my name is Sachin Bhardwaj,
And my name is Rohit Pasula.
and this is our final project on COVID 19 data analysis. The point of interest and purpose for our project was to mainly look at the factors of COVID 19 deaths in the United States. As many lives have been affected by this, and ours in multiple ways, we really wanted to observe the patterns of COVID throughout our country. Some questions we wanted to answer included: which factor played the greatest role in COVID 19 deaths? What states would you be more likely to get COVID in? Where in Georgia resulted in the most COVID deaths, and what underlying conditions grouped with COVID caused the most deaths? These answers would help us to reveal more correlations in this pandemic.
Regarding the collection of our data, we started off by browsing many government databases as well as utilizing the resources that were given to us. We founded our downloaded dataset, a CSV file, on data.gov. We retrieved our first web dataset from a website which we ultimately scraped using Beautiful Soup. This dataset was a chart that actively recorded COVID statistics and updated as time went on. Our last dataset, an API website, was retrieved directly from cdc.gov, providing accurate medical data to our overall analysis.
Our data cleaning process involved a variety of modules that have essentially organized and removed data that is incorrect, irrelevant, or improperly formatted. We utilized the NumPy and Pandas module for our CSV file, as well as applied numerous methods including .drop, .fill_NA in order to remove or update cells in the data. Our downloaded web dataset number 1 was cleaned through the application of the JSON, requests, and Panda modules. JSON was used to convert the API data into a Python dictionary. The final dataset was efficiently cleaned primarily through the use of Beautiful Soup as well as numerous string methods including .strip and .replace.
Alright, so coming to our first insight, we included two rankings for the states. One that determined the percentage of population with COVID, and the other the percentage of population that have died from COVID. We completed this by essentially dividing the total cases or total deaths by the state's population. This was an insight that was significant to know as total cases do not show the true impact of COVID. California was beforehand the state that we would least likely to live in as it ranks number 1 in total cases. However, after our analysis, California fell to 38 in the ranking, while Rhode Island was number 1, with 34% of their population having COVID. As you can see, this insight demonstrated that we should determine the impact of COVID not by their total cases, but by the effect it had on their respective population as a whole. In our next insight, we aim to observe which underlying conditions combined with COVID led to the most COVID deaths, or which condition with COVID made it an even more deadly sickness. We group the data by condition and then use sum to get the total number of deaths for each condition. Next, we use sort values to get the data in a descending order so the most deaths are on the top, and we dropped COVID so we can only look at the underlying conditions. The results were not that surprising, but definitely interesting, as people with diabetes, heart problems, coupled with COVID had less deaths than people that caught both COVID and influenza or COVID and pneumonia. This made us realize how dangerous COVID is when a person has it doubled with either influenza or pneumonia.
To look into this insight more, we decided to create a scatter plot to visualize the data we found. To do this, we again group by condition to sum up the number of COVID deaths for each condition and drop the COVID column so only the underlying diseases would show up. Then, we reset the index so conditions could be a column and the X component on the graph, while the sum of the COVID deaths would be on the Y-axis in millions. The visualization further illustrates the gap of influenza and pneumonia and respiratory failures as the greatest causes of COVID deaths when it is the underlying condition.
Another thing both of us really wanted to know was if location or age group mattered more in resulting COVID deaths. To see this, we first grouped and sorted the data based on age group and summed the number of COVID deaths, then made it into its own data frame while taking the top 10 values using .head. Then we grouped and sorted the data based on state and summed the number of COVID deaths, and then made that into its own data frame and took the top 10 using head again. After this, we concatenated these two data frames and sorted and took the top 10 once again. The results are shown on the slide, and we concluded that age group definitely was a larger factor than location, as more 70 to 74-year-olds passed away from COVID than the total number that passed away in New York, even with New York's population and New York City's population density, which is very interesting.
In this insight, we looked for which states had the best recovery percentages in terms of recovering from their COVID case. In order to do this, we had to create a column that calculated the percentage of recovered cases per state, as you can see in the code. After this, we had to use group by and sort values to have each state with its respective percentage in order. Then we used .head and .tail to get the first and last 5 values, as well as we put a ranking in for these states, so we could see similarities in the top and bottom states. The main similarities between the upper states tended to be less of an older population, while the lower states tended to have more of an older population. Even though this does not account for every state's ranking, it holds for most. For Insight 5, we wanted to see specifically where in Georgia was affected the most by COVID. To truly see this, we looked at where the most deaths happened, specifically in the ages of 55 plus, as most COVID deaths happened in this age group. To achieve this, we first set the data frame so only counties with Georgia as their state would show up. Next, I again filtered the data frame so only age groups of 55 plus would appear in the data frame. After this, we used group by to sum the deaths in all the age groups of 55 and over and sorted them in a descending order. Finally, I created a rank column and set it as the index. Thus, we were able to see the top 10 counties in Georgia with the most COVID deaths over the age of 55. To further visualize this, we created a line graph that represents a table. The similarities we saw in these counties were that the more population-dense counties had the more deaths. In this insight, however, the counties that had the most deaths had the higher populations too.
Another area we both were curious about was how recovered cases fared up to total cases. We decided a double bar graph would be sufficient for this task. We set the x-axis to be the states, while the y-axis would be the number of cases in millions. The two components for the y-axis were the total cases per state and the total recovered cases per state, so we could fully see how many people recovered from their cases in each state that had the top 10 most cases. As we can see from this visualization, for most every state, the recovered cases nearly matched the total number of cases, but the discrepancy between the double bars cannot go accounted for, as they still represent thousands of deaths. In our final visualization, we wanted to see how each age group was affected by COVID deaths, more specifically, the total number of deaths for each group. We determined that a pie chart would be the best visual for this data, as you can see the portion each age group makes. To do this, we used a group by function to group the age groups and sum the data count for each age group. We then used AutoPict to show the percentages on each slice of the pie chart. The age groups listed on the pie chart were difficult to read for some of the slices were too small, so we put in a legend so one can see the illustration for each age group fully. We immediately noticed the huge part of the pie chart that the age group 75 and older took up, 65.3% of the total deaths. This truly astounded us, as we knew older people were more susceptible to COVID, but the size of the pie chart enlightened us to how bad it was. Overall, ages 55 and up were 95.1% of total COVID deaths, while the age group 20 to 24 was less than 0.1% of the total deaths.
We picked this topic and its data to analyze due to its vast impact on us and our peers, and to try to better understand this impact and what caused it. It's clear we did not really understand COVID prior to this presentation, as our hypotheses were not entirely correct. We stated that we would see high rates of death in the extremely young population and old age population, but it was really only true for the older population, as they outmatched any other age group in death count by a vast margin. Combined with the fact that the 70-plus year age group had more deaths in the United States than New York's, California's, and Texas's COVID deaths combined, really led us to believe that age is definitely the most significant factor in dying from COVID, and population or population density does not hold the same prevalence. We also looked at these states with high number of cases and looked at the total recovered cases from that and observed correlations between the higher recovery percentage states and lower percentage states, and saw that states like Utah, that have the lowest percentage of people 65 and over, also have the higher recovery rates, while states like Vermont, with higher percentages of people 65 and over, have lower recovery rates. We also observed how the number of cases per state versus percentages of cases in the population matched up in each state. For example, California has the most cases, but Rhode Island's total cases over population, or the percentage of people in the population that have COVID, is near 35%, which leads the United States, while California is near the bottom of the rankings at 22%. This shows you are more likely to get COVID in Rhode Island than California, as more than a third of its population had it. Underlying conditions were also a large part of COVID deaths, as we saw how things like diabetes and heart disease made COVID extremely deadly to a person, but still how influenza and pneumonia combined with COVID led to the most deaths. To conclude, we did not make any huge discoveries, but this project helped us to understand the pandemic that has taken our country by storm a lot more and to share what we have learned through this. Thank you for watching, and we hope you learned something.